Hello, 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 and welcome to another episode of Mr. Boskin Does Some Math. Today we're doing illustrative math, Grade 8, Unit 7, Lesson number 3, practice problems. Our first question here says write each expression with a single exponent. If we have something being raised to a power, and then we raise that to a power, what do we do? Well, we have 10 to the power of 7 times 10 to the power of 7, because that's what we're doing when we take 10 to the power of 7 and square it. If we take something and then raise it to the power of 2, that means we're multiplying it by itself. So 10 to the power of 7 to the power of 2 is kind of like saying 10 to the power of 7 times 10 to the power of 7. And as we did in the last lesson, when we are multiplying like bases, we just add the exponents. So this is 10 to the power of 14. Now let's look quickly at this. 10 to the power of 7 squared, a 7 and a 2. What do we do to get to 14? We just multiply. 7 times 2 is 14. For the next one, 10 to the 9 raised to the power of 3. 9 times 3 is 27. Next one, 10 to the power of 6 to the power of 3. 6 times 3 is 18. 10 squared times... 10 squared to the power of 3. 10 squared cubed, 2 times 3 is 6. 10 to the power of 3 squared, 2 times 3 is 6. This is kind of neat to notice that both of those, although they look like different problems, do give the same result. 10 to the power of 5 times 7 is 35. Okay, what is next? You've got 1 million number cubes, each measuring 1 inch on a side. If you stack the cubes on top of one another to make an enormous tower, how high would they reach? Well, there are 1 million of them, and each one is 1 inch, so you would have 1 million inches. Your tower would be 1 million inches tall. If you arrange the cubes on the floor to make a square, would the square fit in your classroom? Well, I don't really know. 1 million inches? Well, because it can be kind of hard to visualize. If we had a square with an area of 1 million square inches, what would be the side length? What do we multiply by itself? Because this length needs to be the same as this length. What do we multiply by itself to get 1 million? I kind of think that's 1,000. 1,000 thousands is 1 million. So the sides would be 1,000 inches. I think 1,000 inches is probably bigger than the classroom. Let me check. 1,000 divided by 12, that's 83 feet. 83 feet. Nope, this classroom's not 83 feet long. So would it fit in the classroom? No way. What would the dimensions be? 1,000 by 1,000, or about 83 feet square. If you layered the cubes to make one big cube, what would the dimensions of the cube be? Ooh. So now, this is not my best cube drawing ever. We've got a cube that is 1 million cubes. What are the side lengths going to be? What do I multiply by itself 3 times? Because this by this by this. Length, width, depth. So I need to know what cubed is 1 million. And that is 100? Because 100 times 100 is 10,000 times 100 is 1 million. I believe that is 100 inches on a side. 100 inches on a side, I think that might fit in my classroom. Let's check real quick. 100 inches divided by 12, 8.3 feet? Yeah, my ceilings in here might be 8 feet tall. What are the dimensions of the cube? 100 inches by 100 inches by 100 inches, or about 8 1/3 feet. So as a tower, it's quite a bit longer than if it's just a cube, which isn't really surprising. The cube takes up a lot more. Well, they take up equal space, but because it's taking up more space horizontally, it doesn't go as high. Okay. An amoeba divides to form 2 amoebas after 1 hour. 1 hour later, each of the 2 amoebas divides to form 2 more. An amoeba divides to form 2 amoebas after 1 hour. How many amoebas are there after 1 hour? 2. How many amoebas are there after 2 hours? 4. Write an expression for the number of amoebas after 6 hours. So that would be 2. And we're doing it 6 times. 1 hour, it doubles to 2. 2 hours, it doubles to 4. 3 hours, 4 hours. Hard to write 2 while saying 5. 5 hours, 6 hours, which is 2 to the power of 6. Write an expression for the number of amoebas after 24 hours. 2 to the power of 24. Why might exponential notation be preferable to answer these questions? Well, you can see it in what I did here. 2 times 2 times 2 times 2 times 2 times 2. Multiplying 2 6 times. Multiplying 2 by itself 6 times. 2 to the power of 6 is an awful lot simpler than that. Write an expression for after 24 hours. I don't know about you, but I'm too lazy to want to write 2 times 2 24 times. Why might exponential notation be preferable? It's concise. Okay, next one. Elena noticed that 9 years ago her cousin Katie was twice as old as Elena was then. Then Elena said in 4 years, I'll be as old as Katie is now. If Elena is currently E years old and Katie is K years old, which system of equations matches the story? Elena noticed that 9 years ago, her cousin Katie was twice as old as Elena was then. So let's look at this. K minus 9 equals 2e. So Katie 9 years ago is double Elena? No, because I think that's Katie 9 years ago is double Elena now. I kind of think that first thing needs to be this. Katie 9 years ago is double Elena 9 years ago. So I'm thinking it's going to be D. Let's look at what the other equation is going to be. Then Elena said in 4 years, I'll be as old as Katie is now. So Elena, in 4 years, is as old as Katie is now. So yeah, this is D. So the correct answer is D. Which system of equations matches it? D. We've got a system of equations. Let's solve it real quick, because that's what equations are really for. We know that K equals this stuff, so I'm going to put that stuff into the K. E plus 4, because that's K, and I substitute it into this K, minus 9, because there's a minus 9 there, equals 2, parentheses, E minus 9. Now, I can combine some like terms over here. E plus 4 minus 9 is the same as adding 4 and then subtracting 9 is the same as just subtracting 5. Here I can distribute. 2 times E is 2E. 2 times negative 9 is negative 18. Now, which side has more E's? This side does, so I want to get rid of them from over here. Subtract an E and those will cancel. Do it to one side, do it to the other. Negative 5 equals 2E, subtract E is just E, minus 18. To get the E by itself, we got to get rid of this, so I'm going to add 18 to each side. Those will cancel, and E equals negative 5 plus 18 is 13. Elena is 13 years old. And Katie is E plus 4. 13 plus 4 is 17. Excelente. I believe that was our last one for today. Yep. This has been another episode of Mr. Boskin Does Some Math. Thanks for watching. We'll see you next time.